Yeah, it's all right. Okay, so today we're looking at what's known as the binomial. So, binomial means two, and there's what we call Bernoulli sequences. And they are the basis of the binomial distribution. And so Bernoulli sequences, as I said, there's two. All right, so the features of binomial or Bernoulli distribution is that, first of all, there's two outcomes, and you need to think broadly of what success and failure mean. Alright, success just means the thing you're looking at, and failure is everything else. So, it says two outcomes, it doesn't mean that there's only two possibilities. Alright, so throwing a dice, for example, there's 6 possibilities, but if we're going to treat throwing a dice as a Bernoulli, we would then narrow that down to 2 outcomes. So it might be getting a 3, for example, throwing dice and getting a 3. So success is getting the 3, failure is everything else. All right, so there's that one. The next thing is that the probability of success and failure stays the same.
Oh, I will have my Bernoulli. I know how to spell success.
And the symbol we use for it is P. So that means it remains the same. And the third thing, each trial is independent. Meaning, if you do it 100 times, throw a dice 100 times, for example, each time you throw the dice, whatever's happened before has no effect on what that outcome of throwing the dice. And again, a dice is a good example, so getting a 3, for example, so that's our 2 outcomes, success getting a 3, failure not. The probability of getting a 3 stays the same all the time. The fact that I've got a 4 or not a 3, I should say, not a 3 in the previous throw doesn't mean that I'm any more or less likely to get a 3 on the next throw. All right. Okay, so let's look at an example. And I'm going to use this example to develop a formula that we can use to get probability. So if we throw yeah. Alright. So if we throw a dice 6 times, what is the probability of getting exactly 2 3s? Alright, so what I'm going to do is just use some symbols here. S.
Are we assuming that it's a 6-sided dice?
We are assuming that it's a 6-sided dice, yes. Alright, so we'll let S be represent a 3. So that's our success. And N, we'll let N represent not a 3. And that's our failure. All right. So, let's have a look. So if we threw the dice 6 times, one outcome is we could get 3 first up, then a 3 on the second throw, and then no 3s after that. And so the probability of this outcome is, well, success is 1/6, and we've got 2 of them, and failure, not getting a 3 is 5/6, and we've got, each time we've got 4 of them. Now, this is not the only possible sequence where we can get 2 3s and 4 something else's. There's more options than that. And the question is, how do we get more options? So there are more sequences of throws to give 2 3s. Question is, how do we do that? Well, the key word here is sequences and series come into this. So how many ways can we get? Get 2 3s from 6 throws. So sequences and series, but more specifically, permutations and combinations is involved here. So combinations gives us the answer. i.e. 6C2, or it's also written 6 above 2, gives us the number of ways we can get 2 3s from 6 throws. All right. So, if one option, this one, has this probability, and we get this many ways that we can have two, excuse me, 2 3s, we just need to multiply this probability of this one by how many times we can get that. So the number of ways,
So it's supposed to be 6 over 2, or is that just 6?
yes, 6 above 2. It's on your calculator. This is on your calculator. I've written down where it is.
No, I mean, it's supposed to be like,
With a line.
divide by like 6
Here?
divided by
No,
2.
just nothing here. The 6 and the 2. All right, so hence, the probability of success, which is getting a 2, would be how many ways we can get 2 3s times by the probability of 2 3s. And when you put that in your calculator, and I'll show you how we do that in a little bit, you get 0.2009. All right. So, how can we get some sort of formula out of this? Well, this number here, the 6, was how many times we threw it. So 6 throws. So this here is the number of trials.
So trials, combination successes.
Yeah.
Right.
And the bottom here is how many successes. Yep. And of course the how many successes is also that one there. The 4 on the end is how many failures, which is not success. And then these other two, this one in here is our probability of success. And this one here is our probability of failure or not success. Remember, success and failure is just what we're looking at, what we're not looking at. All right, so we can write that a little bit better in a formula. So let's do that. There we go. So the probability, what you're looking at, equals how many successes you've got. N above X, where N is your number of trials. X is how many successes you're looking for. We're using P as the probability of success. And so those have got to be the same. And then we're looking at Q being not success or failure. And that would be how many trials you do minus how many successes you're interested in. And X has got to be numbers up to whatever N is.
Is that a big P under the X?
That's a little p.
I'm sorry, but I need to.
Right, let's write those definitions. So, N equals the number of trials. P, I'll do X first, makes more sense. X is the number of successes that you want. P is the probability of success. And Q is probability of failure. Which of course, given that for binomial there's just two options, then that would be 1 minus the probability of success. All right. Now, FYI n above x, oops, the mathematical way of work it out is like this.
Excited.
Gotta get excited.
How what?
Factorial
We
is
know
what
what it
that
is.
means.
Is this like the exact equation?
This is some weird special shit.
This is just Mr. Cynic getting excited.
All right, so the exclamation mark means factorial, and 3 factorial is 3 by 2 by 1. So factorial just means you multiply all the numbers down to 1. The good news for you, however, is on your calculator.
What is that?
Literally just explained it.
Yeah, well,
If you go to your keyboard, and I should put it on the board.
It's not in math one.
No, I've forgotten which one it's in.
For example, if n
I
was...
know what they mean by it, but like, why is the word in the is that this the same?
That's just how you solve it.
That's how you solve the So, you see, I say n over x, but there's no divide sign, so it's divide by it.
Oh,
So like,
It's just how to find that.
to explain that, you do n factorial divided by x factorial.
Was I talking there?
so that's, yeah, okay.
Did you reply already?
This is exact. No,
Yeah.
I was listening to Triple J, they were talking about
And you were asking me for exclamation mark.
honey crap.
Yeah. I
It's a
thought I was
UHF.
talking- I thought I was talking to you.
No, I never turned mine on.
I told some random that they're late and should hurry up, so that's
I can't
fine.
find where it is. That's not very good.
No, I was listening to Triple J and they were like talking about some
will
random
it
stuff.
be in the
It was funny.
board?
Yeah, he told me about that. Yeah, he told me about him in Killers. I don't know why. I remember why it was like.
Did Adam speak?
Advanced, that's where it
No,
is.
he was hoping
Something
you
does
did.
nothing with small probability.
All right.
How did you guys catch me? Because I was
Bam.
600 the whole way.
All right, so you go to your keyboard, down the bottom, there's a little down arrow.
Oh, you don't see that, do you?
Down the
Yeah.
bottom, yeah.
Yeah.
Hmm.
So if you click on that and then go to the advanced tab,
Alright.
and then you'll see it somewhere, NCR.
So there's an easier, oh my gosh. There's an easier way if my keyboard stuff's up.
All right, then go NCR.
There's more than just those things on the keyboard.
Like this here, so we can see that. We've done that earlier. Anyway.
Like what? Keyboard and then what?
How do you,
No.
how do you put it in?
Yep.
She hasn't gotten to that point.
Oh, okay.
On.
I was just getting that.
There it is. Right. So there we go. So in your
So you can put your keyboard.
in your keyboard, this little arrow down here, advance.
Do you want it?
There it is. There. Click on that. It's got NCR. So you just put in the numbers. So 6,2.
Yes, please.
And close it off. Oops, wrong one.
I got 15. Is that
Yeah,
correct?
15 ways. Different ways.
What about
Is that
that?
right?
But didn't you come out with some
Yeah,
0.2?
Yeah, because then on top of that, we've got to have the
Times by the probability.
times by the probabilities, exactly. Probability 1/6,
And then times probability.
and then that's squared. And then we're timesing by the probability 5/6,
This is how it
and that's the power of 4.
Oh, that's
So is that the real answer?
That's the real
yeah,
answer.
that's what I got.
Alright, so the bit at the front tells us how many, if we're throwing 6 times, how many times can you get 2? And there's 15 different sequences. Like the one I had, you got the 3 first up and then, but you could get one first and one last, or you get one first and one in any of those places.
So was the first bit without the fractions,
This bit here.
was how to find the sequences?
How many different ways that you can get 2 3s when you throw a dice 6 times. Yes,
These, you always put them in decimal. Or,
yes, we will be
and
always putting these in
on
decimals.
on a test, whatever, how many decimal places would you usually go to?
Usually it would be 4.
4.
Usually,
But it tells you, doesn't it?
but it will tell you how many decimal places, but usually with the binomial they go 4 usually.
Two pages after this one.
We're going to do some.
I have 1, 2, 3.
I have a lot of pages of
Is there more after this?
Almost maybe.
There is more. And another example.
Is that the end of this example?
That's the end of
Yeah,
this
I'm gonna
example.
I'm gonna have it specifically,
Not
like,
like it.
I'm just gonna do all graphs. Because I don't look at graphs, so I can't exact that. So fucking individual things go down, every single one of those is in a whole, where's 2x minus 17? Yeah, but like, no calculator. Don't you?
Right, so we'll get an
This
example.
morning, I was thinking about it, I was like, oh, at least I got my son with it.
Yeah, I am, because that's what they're back.
I genuinely thought about that at the shower this morning.
This one's not as easy.
It's like-
basic group.
I'm actually
Yeah,
fucked,
hold it
like,
to
this is-
I don't know, it's like
warm
it's a
up.
lot less hard than the other one, like the question. It's
Yeah,
like,
but
oh, I'm not.
anything that comes up in
Sorry,
this
what
graph,
colour
The
the-
one that's the pink one's easy.
Yeah, because I didn't know.
The one we had it is just stupid.
this is like my 7 times table.
Like,
Like three functions and there's like 9 answers, but the other one is
Yeah.
like disgusting.
There you go.
Disgusting.
That one goes yellow.
yeah, usually I'm going to get like,
That
like
is so
20
cute.
million. Maybe 7. It's like, I reckon that would be
20 million every day.
Whoa, dude, I have different colours.
I thought it was cool now.
It's like, no. I thought it would be, wait, 23rd. Yeah.
Yeah, was sitting out saying
Okay, we get like a cup and a t-shirt and
I'd run like 3 laps outside.
but the coffee cup's so weird because every time you hold it, it's got like hot liquid in it. I don't change it.
All right. So here we go. On average, 7 out of 10 people use bottle recycling. In a random sample of 8 people, what is the probability at least 3 recycle? So we've got an N, we've got an X, we need a probability of success, and then probability of failure. So N is to do with our sample. All right, so N is 8. And of that 8, we're looking for at least 3. So I need to actually change that from an equals to a greater than or equals. So we want at least 3. So that means we're going to have 4, 5, 6. All right, probability of success, that's where this first sentence comes in, 7 out of 10, so 7 out of 10, which is 0.7. So success is 0.7, failure is 1 minus 0.7, which is 0.3. All right. So what we're after is the probability of x being greater than or equal to 3. So the binomial doesn't give us greater than or equal to 3. What it gives us is just options. So what we're wanting is x equals 3 plus when x equals 4. Actually, I'm using the wrong symbol there. It should be capital X. Plus the probability x is 5, plus when it's 6, plus when it's 7,
Oh, stop it.
and then of course all 8 might. So if we do this, that means we've got to do this all of those times. The good news is that your calculator has a function where it can do all of that all at once. Isn't that handy? So, on your calculator, if you go to, from your main, if you go to interactive, so main screen, interactive, then you will notice that there is one of these down here, distribution inverse dist. So this is the one we're going to be using because we're looking at a lot of distributions, and this is the binomial, so distribution inverse dist. Then we've got some options, continuous, discrete, inverse. So the binomial would be, which one of those 3? Discrete, because it's just whole number answers, isn't it?
Wait, what's the difference between discrete and not discrete?
So discrete has to be certain answers. Like throwing the dice, you can get a 2, you can get a 3, you can get a 4. So they're discrete answers. Continuous would be like a height, for example. You don't have to be 180 centimetres or 181, you could be 180.5 or 180.53 or whatever, so that would be continuous. So the key thing you can say when you want to see whether something is continuous or discrete, generally if you measure it, it will be continuous, if you count it, it will be discrete. Alright, so distribution. slash inverse disk, and then we are after discrete. So we go on to the discrete one, and then we've got all of these
Oh my
to
god.
choose from.
Go for Binomial Cdf. I saw it in the.
I feel like she probably wouldn't know.
Why CDF?
C is cumulative,
This is
which
PDF.
means you add up, and PDF is probability distribution function, so you just get one. So the CDF will do all of that together, the PDF would only do just one.
Do you want to maybe give us a list of which ones were?
So the one we're after is the binomial CDF, this one.
What was that?
Binomial Cdf.
CDF. The C stands for cumulative distribution function. So cumulative means it's going to accumulate all of those things together. So it will do all of that at once. The one above it, the PDF, only just does one at a time. So here we want all of that, so we'll do all of that. So when we go on that, it's going to want some information. So it wants a lower, an upper, number of trials, and the probability of success, POS, probability of success. So the lower is our lowest x, and in this case our lowest x is 3. So that's a 3. Upper is the highest x. And the highest x in our case is 8. Num try is the number of trials. In our case it's 8. And POS is probability of success. All right, and you may or may not have noticed that each time I click on a different box I get a reminder about what it all is. So the probability of success was 0.7. And then you press OK. Now there you go. 0.9887. There you go. Now there's a
Did he actually?
I just associated with gastro.
Gas right now.
When did he have gastro?
He came
Years ago.
on Glentour last year. We got to Melbourne like to go on the through Tasmania. He's like, we told one of the teachers, and they're like, come
Oh,
Who's
seriously?
going on?
home. Yeah, so they sent him home, and then he caught a plane back here. But by the time he'd already infected the bus that he came to Melbourne on, so that became the plane bus, right?
Well,
Well, no, like, I don't even know if that person got gastro. I think he like,
Yeah, I think James.
Sam- 24-hour
Sam,
thing.
Lawrence, Jaden, Andrew, my daughter.
what? I only heard about Lawrence and Jaden. I thought Jaden he got
Why would you take a plane over?
he was
Wouldn't that
seasick,
be
I think,
ridiculous?
and then
We
Lawrence
were-
was
Does it affect everyone on the plane?
Were you in a room with Andrew that year?
Yeah, on the spirit. I mean, we were like freaking out. We're like, we can't be in the room. Like, Ms. O'Brien can't let me in. She's like, guys, stop being idiots. You're in a room with Andrew.
All right, now, excuse me, just a note, a reminder here. If you were asked in the question, this question said at least 3, but if you had something where it said more than 4, so that's greater than 4, because this is a cumulative distribution, it accumulates everything between 3 and 8, including the 3 and 8. So if you had something where it said more than 4, you would need to change that to greater than or equal to 5. And so remember, this is binomial, so there's only whole number answers. You can't have 4.5 or 4 3/4 or whatever. But because this is cumulative, if you put 4 in, it would do everything, include the 4 up. So you've got to make sure if it asks that, just change it up to the next number and then put it in. All right.
You still get the same correct answer?
Hey?
You still get the correct answer?
Well, you would, if you put 4 in, you wouldn't get the correct answer. All right.
Do we still have like heaps more to do?
Hey?
Do we still have heaps more to do?
No, not heaps. Just a little bit. A little bit.
You put it in the 5 lines.
Hey?
You put it in the 5 lines. That's all I got left.
All right.
14 days.
Graphs.
Oh,
No!
is it too late to drop them?
Is this another heading?
Yeah.
A red heading?
It's a big heading. I should have done it all in, but I didn't.
Why did that take me so much time to figure out?
When?
It's a bunch of
Oh my god,
Wait, just new heading class?
yeah.
Yeah.
So that's a new page.
171.
Yeah, I'm just gonna click the whole fucking page.
All right. So if we're going to graph these things, our 2 variables, or our 2 parameters, are n and p. Not Matt. No, parameters. N, our number of trials. And P, our success. Now, for lots of trials,
I brought my own device.
So is that intake number of trials?
no, it's just moving bracket.
Oh.
Better.
Yeah. He's allergic to air.
So.
What? Yeah.
Like,
He's just always itching
what
into.
part of the air?
Like, no, he's just like, he just has to take like Telfast, like, he has to eat Telfast stuff.
So he's allergic, he just got rid of that.
No, like,
No, but like,
it's like a goblet down.
it's like in summer he's allergic to the heat because it like reacts with his skin. And then like in autumn it's allergic to the like leaves in the air, and then in
So it's
winter it's like the
everything.
cold
Yeah.
air, and
So
spring it's
basically
the
he's
cold
allergic to
air.
air, so he just has to take like anti, yeah, all the time.
Six, right?
He just lives up and lives. And when he doesn't, his skin just starts turning red.
Oh boy.
Yeah.
I feel like there's probably something you can get done about
Yeah, telephone.
All right, so if we have lots of trials, then we work out the probability of the success of something. You find that you get a graph that would look something like this. So when x is low, the probability of getting that small, same when x is high, but around the middle, the probability of getting, you know, numbers around the middle is quite high. So you get this kind of curve. Now, if we then look at our change the probability of success, then what we get is where this upper part is moves one way or the other. So if probability of success is low, this moves down here. If the probability of success is high, it moves up that way. All right. So so if the probability of success varies, the peak of the bell
So,
changes its location. So if we had P being quite small, so say less than 0.5, then you have something that looks like that. Probability of success is equal 0.5. You get this one here that I've drawn here, something symmetrical like so. And then of course if the probability of success is greater than 0.5, you get something that looks like that. And the more less than 0.5 it is, the more it moves this way. The higher the probability of success, the more it moves that way. All right, that's all very nice. But what that then leads to is expectation value and variance. And this is just a subheader.
Because we're behind.
Now, if you want to have a look at the proofs of this, by all means, go and have a look at the proofs.
yep, these are both proofs. No.
Wait, what's a proof?
For what I'm about to write up.
A proof is just
Oh,
a bunch of bullshit that shows like.
Like in case we don't
A
believe.
proof is an elegant mathematical derivation of a formula.
You can take my definition.
All those years and that's what I get. All right, so the expectation value of, so what you might expect to get, which is the mean, depends on how many trials you do and what the probability of success is. And the variance, so how much is n times p times 1 minus p, or if you like, npq.
I just can't draw that thing.
that? No.
0 consent.
Mu that has a giant line.
What's that? That's
It's a mu with an extra long tail.
Cool.
So it's just you?
Yeah,
It's not a U, it's a mu.
Is that a little p?
It's a little p, even though it looks like a big P, it's a little p.
How do you remember we did those last session? It's like a fucking Greek letter.
No.
Greek letter. Right,
I've never seen this in-
one example and we're done.
I mean, what?
Yes, well. Oh, no, you can't. You can also do that. Yeah.
You said that you did.
How come you always need to charge your phone this morning? I'm not charging my phone.
That's fine.
Oh, it's mine.
I always forget.
Um,
Try and squeeze it in here.
no. You can try, but I haven't. I'll be sure it's not and ruin the essay. Oh, you like it?
It has no sound. Look at that.
Hmm.
Yeah, finally.
Detectives on the case.
Is this a long example?
No. Sure.
I should be a detective. I can detect everything.
I've moved on.
Someone says change.
I was like, no, we're in the two chapters.
Live off on the edge.
Zeke, what are you doing tomorrow?
I got work in the morning and I was
Cool.
Well, do you want to live somewhere live?
Pardon?
Do you want to live somewhere?
No, we got free ski lift ticket.
Oh, come on.
No, you're working and doing other stuff.
I also have a broken finger.
Yeah.
Which one's broken, Zeke? I'll make sure not to target that one. Okay, I can fucking see it.
Oh, wow.
Oh,
That
shit.
is it.
That is not a thing, guys.
Maybe you should like. not just go with it.
If I strap it,
If
it's
you
like,
go along
when
the
it like
school,
swells
like,
up
yeah,
and
it's
swells
broken,
down, it gets
then you
worse.
pump up.
It's not as much
That's-
easier.
Oh, so it just fix
And I've been
itself.
told by the trainers to like keep moving it and stuff.
It wasn't from punching a
Feel like
goalpost or
maybe
something,
you're
see?
broken. You're broken.
Oh, it was not.
Finger and basic knowledge, just tell you. That's it.
So what does var x actually mean?
Clean.
Variance of x.
Oh.
I don't know what happened, but now I think I have a broken finger and I haven't gone to hospital because last time I went to hospital for a broken finger, they just said, oh yeah, it's broken, get popped out.
Okay. So we've got a random event because we're guessing questions, not looking at them and figuring out the answer, which has three answers.
Give me a minute.
And so x is represents the number of correct answers.
How?
Then there's some information. What do we know? We know
Yeah.
Solution.
that there's number of trials is 30 because there's 30 things that we're guessing,
Correct.
and the probability of success if you're guessing is one correct answer
Out of 3.
out of 3. So that then would mean that your Q would be 2/3. So the expectation value, so for A, how many you would expect to get correct,
What does Q mean?
is just 30
It's
times a third,
P.
which of course is
Yeah, 1 big P.
10. And for part B, the variance is
Oh, I can't do it.
30 times a third times 2/3, which becomes 20/3. And that's it. So 14A and B.
That's nice, isn't it?
14A and B.
14A and B.
Is the graph the beta? Yeah, okay.
They just guess the graph or what?
Did that Adam?
Did you know how it's like
What about-
wherever quantity is it P? Okay, yeah. So with the graph, if P equals 0.5, does that mean
I'd
P
have an
is at 0.5?
Yeah, B in the middle.
You asked me over your
You
boyfriend.
don't need any other.
It's just, I don't know.
So if success is low,
Would you like to explain us our?
success is low,
No.
you're not going to get
I don't want him to get
much in the way
fired.
of success. Say you do something 10 times,
Oh, but it's
the
okay if
probability
they
of
get
success
fired.
is like only
Yeah,
1%.
like the dairy.
Well, like,
Very likely you're going to get
Like,
two in a
yeah.
row.
Just mean with the graph, right? So where 0.5 is, would that be that?
No, I think Tams is already off.
Trials, so it will be half of your trials, so 10 trials, it'll be 5,
Because you write like so many questions for every chapter.
P's
you
numbers.
can come at night as
That
well.
chapter's 14.
Yeah.
These are probably worse than
Yeah.
some
Yeah.
Oh, that your work
Are
right?
you going on Sunday night? I thought they.
I'm
Oh,
leaving,
it
no, I'm
doesn't
leaving
matter.
at 12. Because it's Hobbit weekend, it's like
But
24
the
hours.
probability of success is
Means that
5,
feel
the peak will be
Anyone gonna go ice skate on the weekend?
I really would.
Anyone gonna go to the TV?
Like,
Wait, what's the TV doing?
When,
What is he
you watch that movie Blood Before?
Ever again.
Last time I ice skated, I broke my toe.
Ice skate?
I'm so uncool. No, I can't
You
cross
love
country
ice
ski.
skating.
That was the funniest thing of my life.
Can you come up again?
I'm glad.
Alice?
I really am. That looks like a baby fucking giraffe.
It's the funniest thing. Oh my god. I know, and the lady was like,
Why is
you
it?
would like to go this weekend with the girl. Where are you gonna be? I was like, I'm not going to your house.
Got no P's left, so.
Mr. Bennett.